Let me introduce George. So George is also based out of our Amsterdam office, has a broad background in academia in Norway, Germany, and the UK, doing research and teaching. He has published in more than 60 publications in various areas of AI, NLP, and text mining. George invented several AI pipelines that are used in Elsevier research platforms. So over to you, George.
Thank you very much, Samir, and thank you, Corey. And thanks to all of our guests who are here today. This is a great opportunity for some good discussions. Let me see if this taking control over Corey's slides is working. I don't believe so, Corey. So I might need to give you back control, and I might need to ask you, apologies for this, to slide over them. So I'm going to talk to you today. If we go to the main title slide, about how, in general, in Elsevier, using data science, we are addressing some of the most important parts of the journey of the researcher, but also of other stakeholders in the research landscape. But I would like to start off with our mission. So if we go to the next slide, I would like to just put it in very simple words. We are actually helping researchers and healthcare professionals to advance science and improve health outcomes for the benefit of society. Our ability to combine our high quality content, right, with artificial intelligence, primarily NLP and machine learning are the areas where we specialize, but also analytics and technology. All this enables us to actually create tools that put our users in control, helping them become faster, more efficient, manage all this complexity of information, and at the end of the day, free up a lot of their time to focus on their research goals, right? This helps researchers make new discoveries faster, more efficiently, and also have more impact in society. It's not only specifically for researchers, it's also for clinicians, physicians, and more applied sciences, where we actually provide these users with evidence-based tools that can help them make faster, better decisions at the point of care, for example, and improve both the quality of care, but also the outcomes of their patients. We also work with health educators to prepare today's students for careers in medicine, in nursing, in health professions, providing actually world-class content and innovative teaching and learning tools that make them more successful, more prepared, if you may, for the healthcare practice. So in all of that, AI is actually at the heart of our flagship platforms. And some of them that support our main mission are, for example, Scopus, Science Direct, SciVal, Reaxys, Clinical Key, and of course, Geofacets. So if we move to the next slide, I would like to say just a few sentences of how we do that. At the core of all these capabilities is, of course, expertise, primarily machine learning and NLP expertise. And we use these technologies to increase our content utility, right? Our mission becomes more feasible if we are able to turn all this unstructured, semi-structured, or structured content into a linked data source that we can actually query, hypothesize, get answers from. So off to the next slide, I would like to tell you a few things about the data science population and the expertise we have. At this point in time, we have a bit more than 130 full-time employees who are data scientists in Elsevier. My department alone has something like 32 people in this field. And together with our technologists, we are looking at the population of data science / data analytics / software engineering and technology of more than 1,000 people in Elsevier from its almost 7,000 employees. So this is very impressive numbers. And it shows a bit the magnitude and the investment we've made as an organization in what matters most in the coming years for developing novel technologies. A bit to the next slide. So I had a presentation recently given for some of the Dutch media here in the Netherlands, where I discussed the importance of any company, any modern company, having a solid AI strategy. And in this interview, it will be in public in a few days, I highlighted one of the most important pieces of any organization's AI strategy, which is research collaborations. And in Elsevier, we have actually a portfolio of more than 40 research collaborations with top universities in the globe. We work with Harvard, we work with Cambridge University, Imperial College London, University of Melbourne, a lot of good and top universities. And together, we partner with them, and together we co-develop the next generation of technologies and techniques to support our platforms and our mission. And there is a link there if you wish to know more details about the work we do with these universities and also the research output we've had. We publish a lot of good research in the last years around NLP and machine learning. Let's go a bit into the actual content of today's presentation. And I would like to talk about how we actually put AI at work for accomplishing this mission, and we'll give a few examples. But I would like to highlight the cornerstone of how one can successfully really put these technologies in place. And this cornerstone is what I would call personally the new digital gold, right, which is basically linked data. In this plot here on the right, we actually saw an important piece of our data sources, our Elsevier data sources. And you can see they span across many different types of data and entities and roles, from documents to grants, funding information, to institutional profiles, to author profiles, all of these being annotated and classified with in-house, but also external taxonomies, researcher profiles. And I think the point to highlight here is that for any organization, already having such a fortune to have such great data at hand is a great advantage, but also combined with our ability to link that data and harness this information for the benefit of our users is, I believe, a very unique position in the market. And if you think about it, the outcome of such an exercise with advanced technologies is, in the end of the day, a very rich knowledge graph, which we can query, which we can predict, which we can use to hypothesize and make new discoveries, right? Off to some high-level view of how we actually support the research journey across the different stages. So in the next slide, we see here some of the key stakeholders, right? Our digital estate and platforms can support all these players: researchers, funders, editors, reviewers, authors, people who work in wet labs, people who do research in the field, like in geology or in the oil and gas sector, like via Geofacets, for example. And we really support, in each and every step, we really support our users in a unique fashion. And I would like to show some examples of what this means in practice that are coming up. I have 5 examples put together. So let's go to the next slide. Some of the most recent applications that we developed using very advanced AI technologies, basically deep learning technologies, and more specifically transformers and BioBird, was a technology that we created in order to help the community, the medical community, the biology community, the chemical community, to really fast and effectively identify COVID-19 relevant articles. One of the first things we did in March, therefore, was to put, and you see a screenshot on the top left of your screen, to put together an information center around the novel coronavirus, around the COVID-19 pandemic. And within that, I would say, portal, we have pulled together a lot of interesting resources. And on top of that, we have identified across all of our content using this advanced deep learning technology, the core COVID-19 scientific literature ever since the breakout of the pandemic, but also supporting literature that is very important for clinicians or biologists in order to provide or research on better treatments or even vaccine development from the history, for example, from MERS, from SARS, from historical such cases. And the result is that this information appears to be not only very valuable for us, but also we were approached by the World Health Organization, with which we currently collaborate, and we are the only private organization to provide information related to COVID-19 to WHO. So if you visit the WHO's COVID-19 database, you will actually see, and this is a screenshot here, that they use exactly six data sources or supplier, if you may put it like that, of information. And Elsevier is the only private one. And we actually contribute to this COVID-19 literature from WHO 15% of unique records, of unique data. And we curate furthermore a large amount as well. And we consider this a very important advancement. And to be fair, a very good verification of the value of putting together the high quality data we have and the expertise we have in mining that data. Let's move on to the next use case, which is a use case that many of you might be familiar, perhaps already. It's already in production for almost 2.5 years. In this use case, we are actually helping our users as they read an article without much effort at all, only with a matter of within a click to navigate to a wiki-like page, if you may. We call it a topic page, so that they can collect and learn more information about a specific scientific concept. So this use case is not actually helping our users as they read an article to comprehend and understand the article better by clicking on the concepts and going to the topic page that we have created, looking at the definition of the concept, related concepts, and the most important book chapters and journal articles that we have on this concept. But it also helps the general public. These topic pages are publicly available, they're free. And they have also started overtaking the appearance of the Google information boxes when you're Googling for some scientific concepts. Sometimes you might see an Elsevier topic page instead of the wiki page or instead of something else. And we consider that a great success because it's, again, one more sign that the information and the data we have and the infrastructure we have can actually really help the community digest the scientific information better. So we went from the wisdom of crowds / Wikipedia to the wisdom of experts, in a sense. And on the bottom left of the corner, we can show you here also a bit of the success of the traffic. Currently, the topic pages have something like 50 million unique visitors per month on average. Off to the next slide. Many thanks, Corey. Another success story has to do with our ability to put together and link the funding information that we can collect, not only in our own content, but also in third-party articles, in third-party content, articles from other publishers, and link that together with structured information sources, for example, grant information that funders supply openly and publicly, to provide a unique, actually one-stop, one-shop stop experience, if you may, for our users who are looking for new funding opportunities. So what you see on your screens on the right is a technology we have developed based on advanced machine learning and NLP, where we automatically extract the funding information from articles, from any article, may that be in PDF, XML format, or whatever other format have you. And in turn, we identify specifically the funders, the grants, the relations between funders and grants, and we also do the extra step and link all that information with information that the funders provide. So for example, if we know in this specific case, if I can see, well, there is an NSFC grant with a specific ID, one of the biggest funders in China, we have this information also on the other side from the Chinese funder, and we can provide even further information, what was the budget of this grant, who were the principal investigators, what other publications, but more importantly, to allow our users to explore funding opportunities, right? So if we go to now the two last examples I have for today's presentations, or I think three, it's another three. This is one example from the life sciences domain, right? As I mentioned, our mission is to serve researchers across the board of their application, of the field of application. And this one is from the life sciences. As you know, one of our flagship products, Reaxys, is considered one of the major sources and databases for searching and reading information about chemical compounds. And what we did recently, actually, this is a very new project almost a year now that we have started designing, developing, and are about to put in production end-to-end, is we have started accelerating the information we can collect on chemical compounds by mining automatically another data source, namely patents, right? If you think about it, patents is a very important data source, especially in pharma and in bio applications. A lot of good things as information are mentioned there, but it has a lot of peculiarities and challenges. So we have managed to accelerate the way information arrives to the axis around chemical compounds, but by not only looking at scientific publications, but also expanding to patents. And we've done that with automated techniques, again, using deep learning technologies, for example, annotations of compounds, extraction, and linking to databases. At the end of the day, we have managed to shorten the average period that information about a specific compound arrives in the axis from what used to be 20 to 30 days, also with a combination of some manual process, down to 3 to 5 days with a fully automated process and with extremely similar quality with what it was before. We find this extremely fascinating application and in general finding on what the current technology in the state of the art in NLP and machine learning can deliver, and which we have started harnessing for many of our applications. Let's move on to two examples which are closer perhaps to the domains of the audience. One example is coming from a geoscience use case which we worked last year, hearing and understanding a bit the pain points of our users and our potential customers in the previous customer days, with regards to the importance of identifying analogs and mining analogs directly from the data sources and the content. So what we did, we actually put together a relatively simple machine learning pipeline that you see on the screen towards the right. These are the different steps that we are taking both for pre-processing, the NLP application. Nevertheless, with important and state-of-the-art technologies within some of these components. For example, for some of the machine learning components, we used at the time last year, some of the latest were the Elmo embeddings in conjunction with some deep neural nets to be able to extract entities, for example. This pipeline was applied in a very well-curated data set where we actually trained our algorithms to extract and identify analogs. And on the left, you can see some of the preliminary results we have currently. You can think of them as rock curves, areas under the curve performance, which shows more or less, and on the green it's the baseline, the random baseline, and all the other curves are showing basically a lot of good improvement that our machine learning techniques have started learning to automatically identify the specific types of analogs for which we trained these pipelines in this use case. Last but not least, the next example I have is an example that pertains to also some of the discussions that we heard in the previous presentations, also from some of our colleagues from BHP and the other organizations, with regards to the importance of any such platform, such as Geofacets, to be able to automatically classify or tag, if you may, content, right? And that can be actually your content, into thematic areas, into subjects around geoscience and geology. So recently we have started developing some very novel techniques. Initially, some of these techniques based on simple artificial neural nets, not deep neural nets, and taking advantage of the surface appearance of the file, some metadata and their structure in your specific file system, right? We had a use case there. And we started training some such systems to understand whether we are able, with only this information, surface information for the files and some simple metadata, to classify geological content into general categories, right? For example, geophysics or exploration, and so on and so forth. In the middle of the screen, you see more or less how this looks like as we put that machine learning system into the training. Epoch after epoch, the system is learning. And at this point in time, we are able to achieve accuracies almost in the 80s for a number of categories, classifying content in a number of categories. And in the very next period of time, we are putting into work even more advanced deep learning architectures and technologies, such as the one you see on the left. This is a BERT. We're planning to use also similar ones like the Roberta or Albert architectures, which are more efficiently able to train on these features. And we are actually going to explore how we can use the state-of-the-art technologies to even improve the simpler artificial neural nets in this task. So this is what I had to mention at a high level with regards to our abilities to harness scientific information using AI. And thank you very much for your attention.
Thank you, George. Inspiring as always.